All right, this is AP Calculus. This is going to be the worksheet 5-5 solutions. We learned a bunch of different antiderivatives. My hat just fell apart. I'm not going to wear this thing. My balloon fell out. All right, so for the just a reminder to remember the signs. If it's the antiderivative of S, anti-same is change, so it changes to a negative. And anti-C, anti-change means same, so it's going to be the same sign. Just like before we had S, if it was the derivative is the same, derivative of C is change. All right, so let's do number one. And I should put key up here. This is the key that we are talking about. For number one, the inner is 3x. The taxman, there is no taxman. The derivative of 3x is 3, so I'm going to pay taxman 1/3. All right, so when I rewrite my integral, my new integral is 1/3. I'm paying taxman now, and just rewrite everything that was the same. So cosine 3x and then dx. Okay, now I'm going to actually take the antiderivative. So anti is obviously going to change to a 1/3 sine of 3x plus c. Then the question is it a positive or a negative? So anti-change means same sign, so it's going to be a positive. And there's your final answer. Box it. And then I'm going to test to see if I got the right answer. So if I take the derivative of 1/3 sine, it's going to turn into, S stands for same sign, so it's going to be 1/3 sine of 3x, and then times dinner, that was doubter, so times dinner times 3, and notice that the 3's will cancel out, which means we'll be left with sine of 3x, which is what, whoops, what have I done? I forgot to change it, darn it. I changed it to a cosine here. Cosine, yeah, so the derivative of sine is cosine. And then I get just normal cosine of 3x, which is what I started with. Give myself a check. All right, moving on to the next question, number 2. My inner is 2x plus 3. The taxman, there is no taxman. The derivative of 2x plus 3 is 2, which means I'm going to pay taxman 1/2. Rewriting this with paid taxman is 1/2 down here of sine of 2x plus 3 dx. All right, so now I need to take the antiderivative of that. Taking the antiderivative of sine gives us cosine. Anti-same means change, so it's going to be a negative 1/2 cosine of this 2x plus 3. And don't forget our cake plus c. There is our final answer. Box it. Let's go ahead and check our work down here. If I take the derivative, I still have this. So c stands for change. I'm going to have a 1/2, a positive 1/2. I'm going to change the negative to a positive. And it turns into a sine from a cosine to a 2x plus 3 inside. And don't forget your dinner, that was doubter. Dinner is times 2, and then notice that 2 and 1/2 will cancel out, leaving us with sine of 2x plus 3, which is what we started with. All right, give myself the check. I know what I'm doing. Let's go on to number 3. The inner is x to the power of 3. Taxman is x squared. The derivative of x to the power of 3 is 3x squared. Luckily, when I pay taxman, my variables will cancel each other out, and I pay taxman 1/3. So rewriting with paid taxman, this x squared is going to turn into a 1/3, so a 1/3 cosine of x to the power of 3 dx. Let's go ahead and take the antiderivative now. The antiderivative of cosine is going to be, well, anti-change means same, so it's the same sign. So 1/3 is going to switch over to a sine from a cosine, and my argument inside here is x to the power of 3. Don't forget r plus c, our cake. There is our final answer. Let's go ahead and check our work. So if I take the derivative of sine, it's s for same sign, and it's going to be a 1/3 cosine now of x to the power of 3. That was our doubter multiplied by dinner. The derivative of this inner is 3x squared. Notice that the 3 and 1/3 cancel out, leaving us with a x squared out front. This x squared out front, there it is. All right, so we've checked our work. Give ourselves a check. On to number 4. So number 4, our inner here is 4x. Our taxman, there isn't a taxman. Our derivative of 4x is 4, which means I'm going to pay taxman 1/4. So rewriting this with taxman being paid, I have 1/4 out front, and then copying down everything else, I have that secant squared of 4x dx. Let's go ahead and take the antiderivative. Antiderivative of secant squared is tangent, so I have 1/4 tangent of 4x. Don't forget our cake, our plus c, and box it. All right, so taking the derivative to check our work, taking the derivative, I have 1/4 secant squared of 4x. That is our doubter. And then multiplied by the dinner, the derivative of 4x is 4. Notice that the 4's cancel out. The 4 and 1/4 rather cancel out, and I'm left with just secant squared of 4x, which is exactly what we started with. Give ourselves the check. We got that problem correct. We are on to number 5. All right, so this one is another way of writing the question. This might be confusing, especially when you see the test. You see this problem on the test, and you're like, wait, am I asked for the derivative, the antiderivative? What is it asking? If I'm giving you the derivative and I'm saying, hey, get back to f, it's asking for the antiderivative. A little bit weird for asking that, but get ready for those. So I'm really asking, what is the integral of 2x minus cosine of x, all of that in parentheses dx. And just as a kind of minor note, this dx needs to be multiplied by everything on the inside, which is why I put these square brackets. That won't make sense much until we learn about this next year when I talk about what it means graphically, and you'll be like, oh yeah, dx is like the thickness of that infinitely thin rectangle. But until now, just know that this dx is being distributed into each of these. So when I take the antiderivative, I'm really taking the antiderivative of 2x and then worry about antiderivative of cosine of x. So another way of thinking about this, and I'll write this down, is the antiderivative of 2x dx minus the antiderivative of cosine of x dx. When I actually take the antiderivative of 2x, that's going to go up a power, so 2x to the power of 2 now instead of 1, and then divide down by that 2. I would add my c right now, but really I need one c between these two problems, so I'm going to just go on to the next one. So minus the antiderivative of cosine. Well, that's going to, anti-change is same, and that's going to be the same sign, so it's going to be just sine of x. And then don't forget your plus c. I can simplify that just a little bit by canceling out these 2's, and I get x squared minus sine of x plus c. Final answer, and box it. Next problem, number 6. Another way of asking the same thing. What is the, if I'm knowing that the derivative is cosine of 2x, take the antiderivative to get back to y. So what is the integral of cosine of 2x dx? And to do that, I'm going to use Taxman because the derivative of the inner here is 2. It's not 1. So I need Taxman. I need to know that the u is 2x. I need to know that the Taxman, there isn't a Taxman, so just 1. And then the derivative of 2x is just 2, which means I'm going to pay Taxman 1/2. When I rewrite this, paying Taxman, I am now left with the integral of 1/2, and then rewriting all this other stuff. Cosine of 2x dx. Okay, now I can take the antiderivative. When I take the antiderivative, anti-change means same. So it's going to be the same sign. It's still positive. 1/2 sine now from cosine of 2x, don't forget our cake, plus c. Final answer, and box it. Moving on to number 7. So I'm taking the integral of this thing. I need to use Taxman again because this derivative of the inner is not 1. So u, the inner here, is x squared. Our Taxman knocking on the front door here is 2x. Our u prime, the derivative of x squared, is 2x. Check it out that the 2x and 2x cancel each other's out. So I'm paying Taxman 1. All right, so our new integral, I'm running out of room, so I'm just going to do it down here. Our new integral, let's do it in green, is the integral of 1, or just nothing, cosine of x squared dx. So from here, I'm going to take the antiderivative. When I take the antiderivative, anti-change means same sign. So it's going to be just a positive still, sine of x squared. Don't forget our cake, plus c. Final answer, and box it. Next problem is number 8. So I'm going to use Taxman yet again. So u is equal to 4x. Taxman is 3, and the derivative of u is 4. So I'm going to pay Taxman this fraction of 3/4. Rewriting our integral now is the integral no longer of just 3, but 3/4. Integral 3/4 sine of 4x dx. Yeah, I'm noticing that a lot of these are not being formal. I should really have a dx on some of them. I don't know why I just noticed that now. Maybe I'll change it for future years. Now that I have paid taxman, I can go ahead and take the antiderivative. The antiderivative of sine, anti-same, so it's going to be change of sign, so it's from a positive to a negative 3/4, and sine turns into a cosine of 4x. Don't forget your cake plus c, and that is our final answer. Box it. Moving on to number 9. Ooh, lots of negatives. We'll be careful here. I do need to use taxman again because this is the inner. The inner is negative x. The derivative of the inner, the dinner, is -1, and -1 is not 1. Anything that's not 1 is taxman. So taxman, I need a u, which is negative x. I need a taxman. Taxman is actually going to be -1 in this case because I have a negative out front. So -1, and then the derivative of u prime, is -1. The derivative of negative x is -1. So I'm going to pay taxman 1, which is kind of nice. It means I get to get rid of this negative in front of the cosine. So our answer, well, rewriting this with taxman, I have room on the right, so I'll do it right here, is the integral now of not negative, but positive cosine of negative x dx. Once I've paid taxman, I can go ahead and take the antiderivative. The antiderivative now of cosine, anti-change, so same sign, same positive, so it's going to just turn into a positive sine of negative x. Don't forget our cake plus c. Final answer, box it. All right, we have, is it just 2 more problems left? All right, we're almost done then. So number 10, I'm kind of distributing this integral, but also notice that the inner for both of them is 2x, which means I can apply one use of taxman to both of these problems. So I'm using a bit of a trick. I'm knowing that our u for both of these is 2x. Our taxman for out front, I guess right here, is 1. So our taxman here is 1, and our derivative of u is u prime 2. So I'm paying taxman 1/2. And I should mention again, this 1/2 doesn't get applied, like I guess you could distribute it into both of these two terms, but I'm really thinking of 1/2 as kind of out front of the entire set of parentheses. So when I pay taxman, do I have enough room here? I think I do. When I pay taxman, this is now the integral of 1/2 all the way out front of all of this stuff, sine of 2x plus cosine of 2x, and then all of that is multiplied by d of x. Okay, I realize now that I didn't have enough room unless I scooch this over a little bit. That looks a little bit better. Move that dx up. Okay, didn't grab that d part. There we go. And then from here, I can take the antiderivative. So the antiderivative, I still have that 1/2 out front. Antiderivative of sine is cosine. And anti-same means change, so it's going to be 1/2 times this negative cosine of 2x. And then antiderivative of cosine, anti-c for change, so it's going to be the same sign, so it's still going to be a plus here instead of a minus, of sine of 2x. And don't forget your plus c. And I'm realizing now that I have all this room down here and I'm not using it, so I'm just going to move all this stuff down to the bottom area. Perfect. And then I can make this x move up a little bit. That looks much, much neater. And that is the final answer, so I should be boxing it. All right, we are on the last question now, number 11. For number 11, we are going to use u substitution. We're going to say our u in this case is going to be cosine of x. Again, just kind of randomly choosing at this point. And when I take the derivative of u with respect to x, du dx, that is going to be negative sine of x. Again, our trick with u substitution is solve for d of x. D of x is just going to be the reciprocal of whatever this is, so 1 over negative sine of x, and then slap on a du. So when we do our u substitution, our integral now becomes the integral of sine of x times cosine of x. Oh, sorry, our cosine of x is not there. Cosine of x turned into a u. So it's sine of x times u times d of x, and then d of x got substituted out. D of x is actually this thing right here, so times 1 over negative sine of x du. All right, well now you'll see a lot of things cancel out, which is really nice. Sine of x and sine of x goes away, so this is really turning into, if I simplify this, this is really the integral of negative u du. which is really, really easy to take the antiderivative of. So taking the antiderivative, it's going to be negative u. It used to be to the power of 1. It's going to go up a power to the power of 2, and then divide down by 2. Don't forget your plus c. There it is. And then I just have to plug u back in. So what was our u? Our u was cosine of x. So this is equal to negative cosine of x squared, or normally I put that squared out front, all over 2 plus c. And notice that in the answer key, I have it slightly different. There are 2 different answers to this one. If I come over here to my answer key for number 11, I chose my u to be sine of x. In this case, I chose my u to be cosine of x. So both of these are the same. So I'll go ahead and I can probably just screenshot this to add it to my notes. This is another possible answer that you could have got. So I'll say, or this answer right here. So both of these are potential answers, and go ahead and box both of them. So box this one, or box this one. Cool, and that concludes worksheet 5-5.